Hello. Hi, Hongjie. Are you able to hear me? Okay, please check your sound system. Make sure you're able to hear and see me clearly before I start. Can? Oh, you have a fabulous day today. Great. Okay. Okay, now we are going to start with today's session. We are going to learn more about. Do you know what we're learning today? Okay, today we are going to learn more about constant difference. Okay, now, but what exactly is constant difference? Okay, Jose, do you have any idea what constant difference is all about? Hi, Victoria. Okay, we're just starting on the first on the third session for today. We are going to work more about constant difference. Now, constant difference sounds like what? In the past two lessons, we have learned single unchanged, total unchanged. So today we're working on constant difference. Now, constant difference actually means when things or in terms of the differences between two items or two person does not change. So can you think of any scenario that you have constant difference? Okay, now remember we are learning on the topic of constant difference. Can anyone give me any example of what kind of situation or in what kind of situation would there be a constant difference? Can anyone think of any situations? I can think of one. For example, between my two containers, I transfer 10, okay, not transfer, I received $10 from, this is my pocket money, okay? My dad gave me $10. My mom said that I got to give her $10. Do I make it? Oh, sorry, that's not different. Okay, sorry. Constant difference. Okay, between you and me. Okay, I see. Sorry. Between the two of us, each of us have a different sum of money, but the two of us gave away $10 to our friend. There's a difference between the two of us changes. There's no. Okay. The difference between the two of us does not change if we both receive or we both gave away the same quantity. And second scenario that has uses constant difference and is a very common one is age. The age difference between two persons will never change. So today we are going to cover two types of question. Okay, so key thing about constant difference is the difference doesn't change. And I'm going to cover two questions. The first one I'm going to touch about on age. And second one is on equal change. Equal change meaning you could be receiving the same quantity or you remove the same quantity. Okay, so two types of question is our main goal for what we're going to learn today. So first of all, age. Now, as usual, the age between two persons is fixed. For example, the age difference between you and your siblings, if you're 2 years older than your brother or your sister, 10 years down the road or 30 years later, you're still 2 years older. Okay, so the age between two persons is fixed. It doesn't change at all. Okay, so when we're working on questions relating to age question, we can always draw. You can do model drawing. You can do the BCA table, and it's fine. So today I'm going to work on the BCA table. Now, do all of you remember what is the table about? Do all of you still remember how we draw that table? Yes or no? Okay, now for the same thing, you can draw the before table, you can do the BCA table. You can still draw your model drawing, it is fine. Okay, so I'm going to go through two methods. I'm going to, first of all, I'm going to draw for you the model. Second method, I'm going to draw for you the table. And then we will work on the solution. Okay, so model, then I go through table. Okay, don't worry. Model, table, then solution. Okay, first of all, let's take a look at model drawing. Um, Sharon is 6 years older and her father is 30 years older. So Sharon is younger. So I'm just going to draw a box. And I'm going to draw a longer bar for the father. Okay, very good, Victoria. That's the right understanding. This is for Sharon and this is for father. This is 6 years and this is 30. Okay, this is 30 years old. Then they mentioned about in how many years time will Sharon age be if her father age is 4 times her age. Now, in how many years time, it means that the both of them going to get older. Because in how many years time means would it be 3 years later? Would it be 5 years later? The age difference between them. the number of years later. So if I want to reflect that in my model, then I would have to draw that at the end of my model. So I'm going to draw like a little portion at the back. This shows the number of years later. Okay, so let me just draw back again. This is the age, number of years later. 8 type 1 answer. Yes, very good, Victoria. Okay, then this became, after I do this way, right, the father became 4 times her age. So in this case, am I right to say that this whole bar is now 1 unit? And it's not drawn to scale. I can also cut it into 4 equal parts at the back. This is now 4 units. Does it make sense? Okay, so after they both added a certain years, Sharon became 1 unit and the father became 4 times. Okay. So in that case, the difference between the two of them, the age difference, is 30 minus 6, which is 24. This is their age gap, and it's constant. Okay, because it's constant, therefore 3 units is the same as 24. Then we can work from here. Okay, so let me see what you guys are talking about. Oh, okay, let's just focus on the question first, okay? Let me just, okay, don't worry. You can only be saying my work, so no confusion. Okay, so if you take a look at the difference, the 3 unit stands for 24. So 1 unit will be 24 divided by 3. Yes, and you can get 8. So it means that 1 unit is 8. So you can compare either the father or Sharon. It gave you the same answer. So I'm just going to look at Sharon. If Sharon is now 6 years old and X number of years later, she became 8 years old. So the difference will be 8 minus 6. Yes, become 2. So the answer will be 2 years' time. So this is one way which we are using the model method. Now, of course, you can say, teacher, the last 2 weeks we have been using the BCA table. Can I use the same method in this question? Yes, you may. I'm going to show you how to put that into the before change after table. Okay, so in terms of the table, yes, very good. Okay, Jay, you got the right answer. That is very good. Okay, now I'm going to quickly write out the table for the BCA table. So for any one of you who are using the table, you can use this as a reference. Okay, so Sharon, father, difference. Oh, I got missing one line. Let me draw one more line. Before, change, after. So Sharon is 6, father is 30, difference is 24. That's the same thing as what we did over here. Same part, okay? Then the change is, I don't know they added in how many years later, but I know that the father became 4 unit. Sharon is 1 unit, difference is 3. Therefore, this must be equal. Get it? So if you use the table, you realize that you can continue from these steps onwards. It has the same information. It's just whether you prefer to draw it in a model or you prefer to do it in a table. Okay? But one thing to take note of is whenever the question asks about age, you have to remember it links to constant difference. Okay? An age gap between 2 persons never change. So a classic question is always about age. Definitely, Victoria, you can stick to your model, it's fine. I'm just trying to expose you to different type of method. Okay, there's no right or wrong which method is the best method. It's just what you prefer. Okay, so now this is type number 1. Next, I'm going to talk about equal change. Now, what exactly is equal change? Like I mentioned, equal change could be both of you. Keywords are, it has to be both receive or give away an equal quantity. Okay, an equal number. If both of you receive or gave away a same quantity, the difference between the two of you did not change at all. Okay, it could be a class, 10 girls left the class, 10 boys left the class, possible. It could be number of items, it could be money. It comes in various form, but just look out for keywords. So in this case, they mentioned that Teen A has 486 sweets. Teen B is 1,262 sweets. Keywords over here that tells me that this is about constant difference will be the word. Equal number of sweets will remove. Keywords, equal number. So when I know that equal number has been removed, it tells me that, hey, I don't think there's any difference to them because the difference remained the same. Then Teen B became 5 times the number of Teen A. So same thing, we can do model, we can do table. Both method is the same. Now, I'm going to give you guys 1 minute. Okay, you can be drawing out your own models. You can do the table, up to you. I'll give you 1 minute to come up with the diagram. Then I will go through with you the calculation, okay? So 1 minute starts now. Get me your model or get me your table. Either method will do. Okay, if you prefer model drawing, draw me the model. If you like the BCA table, get me the table. Okay, now while you guys are working on it, I will just briefly draw the models and the table so that we can go through both of them together later on. Okay, if you think you're done with your model drawing, do let me know. If you're done with your model or you're done with the table, just let me know. Okay, good. Lucas, you use BCA method, no issue. Oh, let me see, Victoria, you got an answer. Let me just check for you if that's the right one. Excellent. Okay, Victoria, excellent. Victoria, you use the modern method or you use the table method? Okay, definitely. Okay, so let me go through with you guys on the model and the table. I'll go through two of them and you can pick out which one you prefer and make sure that you get the right model drawing or you get the right table fill of the right details. So let's take a look at model. I know that Teen A is 486. I know that Teen B has 1,262. Anybody help? Okay, Hong Jie, I realize that you've been raising your hand. Let me unmute you. Yes, why? Yes, hi. How can I help you, Hong Jie?
Nothing.
Nothing. Okay. Okay, let me unmute you. Okay. So once I get the two models, right, they say both of them has an equal number of sweets being removed. Now, for those who draw your models, please be very careful. If you want to draw the parts being removed, please do not cut from the front, meaning that I don't want to see students who draw this way and tell me this is cut away. This is wrong. If they cut away an equal model, equal parts, please reflect that information. I usually like to put it at the back of it. It's neater and it's easier to compare. I will cut it from the back. I will usually cut it this way to show that it is equal. This is now your 1 unit, and this became your 5 units, like this. So if you do notice that this is the difference, and that tells you the difference is equivalent to your 4 units. Or we can also do that in your BCA table, 486 for A, 1,262 for your B. Both take away a portion, which I don't know how many. B became 5 units. A is 1 unit. If you're in a table, the difference between them is 4 units. The difference between them, we can take 1,262, take away 486. This way, I will be able to get a value of 776. This way. You see? Both give you the same weight. So after you get to this part, do everyone know how to continue? You can, right? For the model method, you realize that this stands for your 4 units, because if you look at your model drawing, that is where your 4 boxes is. And then if you're looking at our table, the difference remain the same. So these are equivalent. So 2 methods, same solution. Okay, so to continue from here, I take my 700, okay, I got no space, so I'm going to write it over here. 776 divided by 4, because it is equivalent to 4 units. After we divide it by 4, you can get it as 194. Now, you can find either one of them. Okay, if my 1 unit stands for 194, what is the changes? Because they want to know how many seats was removed from each team. And since the keyword is each, please do not help me. Please do not take the total and minus for me. I want to find each team, not the both team. Okay, so we can take 486, take away 194. That way the difference will be 292. And that will be my answer. That's it. Pretty straightforward, right? Okay, so remember constant difference. What are the 2 kind of scenario? Who can tell me? The two very common scenario that tells me that, hey, this must be about constant difference. What is the two different scenario? Can anyone recall the 2 types of questions that falls under constant difference? Age, very good. One more? Equal, yeah, so remember, equal change. 2 types of question. Always remember for work problems, to score well in work problems, you must be able to identify the strategy or the heuristic method. So always be able to identify what kind of scenario or what kind of questions fall under what heuristic method. So anything that got to do with age, you know, is constant difference. Anything that you see, they write remove the same quantity, add in the same quantity, receive the same quantity, then it tells you equal change. Then use either model drawing or table method. Straightforward. Okay, so recap, we have learned 3 different types. So far we covered 3 types of questions, as in 3 different sections. Okay, so we have the single, total, and constant difference. So these are the 3 things we have learned. Okay, and next lesson, we are going to work on all changing, equal concept, and working backwards. Now, since I have already covered the first 3 types of basic questions, now what happens on the next lesson is that I am going to give you a short link, okay, which consists of 3 simple questions that I need you to work on it. Okay, the post, I will let you know how you can access to it. Don't have to worry for now. Okay, by next lesson, you'll be able to receive the link. It's just a recap on the first 3 sections to make sure that all of you actually understand how to apply. Then we will work on the next 3. So this section, the whole series is 6 sessions. And don't worry, Victoria, even if you did not attend the lessons, I will give you a link that you can access after the lesson. It's fine. You don't have to worry about that. Okay? It's a link that you can access after the lessons. It's not during the lesson. So even if you miss out the lesson, you can always view the video. Okay, it's being recorded. So anything you have missed out, please look through the videos again, okay, to learn more about it. So to remember, we covered the first 3 and we have 3 more sections to go. Okay, and before I end today's section, I just want to have a quick feedback from all of you. Any of you find that the timing is too late or too early for the TLS section? Any of you find that the timing is too late or too early, that you will prefer the session to be earlier or you prefer the session to be later? Any feedback for that? Because we are planning out the next session, so we are looking at whether we need to change the timing or not. And when is 5 the timing? Okay, Jay, you prefer slightly earlier. Okay. Okay. Anyone else have any? A little bit, late, little bit late. Jiating, I don't understand. You want it a little bit late or a little bit earlier? Earlier or later? Later. Okay, good. Okay, so key thing here is that after this section of this series, the next series we are working on fun puzzles. Okay, so just that you know what's going to happen after this sixth session. This sixth session we are working on heuristics. The next sixth session we are working on math puzzle. Then we'll take turns again. So it just it will be like heuristics, fun puzzles, heuristic, fun puzzles. Okay, great. Okay, great. So that's all for today's sessions. I'll see you guys next week about learning more about all changing. Okay? So that's all, and thank you everyone for attending today's lessons. I'll see you guys next week. Bye. Bye. Hope you learned what you need to. Okay, bye.